Hello everyone, welcome once again. Myself, Mr. Mukul Barwant. I'm your course conductor of a subject number BO336, semester 5th. Previous we have seen the three chapters of a computational botany. In this lecture, we are going to see next chapter of a computational botany. That are the chapter number 4, measures of a central tendency of a group and the ungrouped data. That are the presented by the Barwant MM. The topic on the central tendency. Let's see in each every chapter we have see before the seeing the chapter we have to see the content of the content of the unit or the chapter. In this we have to see the simple arithmetic mean, its merit and limitation, average position, median, mode, and their merits and the limitation. Next, first we have to see what is a central tendency. The values of variable tends to the concentrate around the some central value of a observation of an investigation, which can be taken as a representative for the whole data. The measure of central tendency refer as a central distribution of data, such as a average. They give an idea about the concentration of a value in a central part of a distribution. Measure of central tendency. There are the three important measure of central tendency: mean, mode, and the median. Let's see what is the central tendency. The values of a variable are tend to concentrate around the some central values of data, and that values represent whole data or the whole population. That is known as a central tendency. That is simple concept. There are data is given in a 10 numbers: 1 2 3 4 5 6 7 8 and 9 and 10. That data are given. We have to determine central tendency. We have to determine central value of all our data that represent that data. That is known as a central tendency. We have to centralize data in a one unit. That is known as a central tendency. Let's see what is a mean. Mean is the average of a data. Mode, most commonly occurring value. It is simply concept of the simply meaning of that concept. Mean is it is nothing but the average of the data. And mode it is the most commonly occurring values in data. Then median, the middle value of the data, that is known as a median. Let's see one by one. Let's see simple arithmetic mean. Mean, it is nothing but the average. Mean locate the central distribution, also known as a arithmetic. The center of distribution of data is known as a mean. Most common central measures. The mean simply it can be defined as the sum of all values divided by total number of atom of a set. That is known as a mean. Mean is represented by summation of all observation such as x1 plus x2 until to xn divided by number of atoms or number of observation. It is the most commonly used measures in the center of data. Is also referred as a arithmetic mean. In the exam they can ask for the two ways. They either ask for the simply mean or the arithmetic mean. A computation of a mean. There are the generally we found the two types of data: ungrouped data and the group data. They are simply classification. Ungrouped data, when data are given in a group such as for example 1 2 3 4 5, that is known as a group data. And the ungrouped data, the data are given in the form of tables, that is known as a ungrouped data. For the calculating of a group and ungrouped data, that having a specialized formulas. Let's see ungrouped data and the group data. For example, score of 50 student mathematical quiz of 25 items. The highest score is a 25 and the lowest score is a 10. Here are the scores are given: 25, 20, 80, 80, 17, 15, 15, 15, 40, 40, 30, 30, 12, 12, and the 10, 10. That are the data are given. Firstly, we have calculate the sum of all data. We have calculating the sum of all observation, that is a 2 to 8, and the number of observation is 15. Therefore, we have calculation and we get a mean 15.2. That is the group data type of problems. It is simple way we can calculate it. In this way simple. There are also one type of a fractional example: 3.3, 6.1, 5.8, 6.1, 3.8, 2.7. That fraction that we have do not need their fraction number and the fraction calculation, but we have to calculate that fraction, such as 3.3, 6.1, 5.8. That summation we have to do and the divide by number of observation. Let's see ungroup data. The data are represented in the tables. There are the two variables are given: first variable frequency, and another first variable is a x variable, and second variable is a y variable. Let's see what is our problems. The problems represent two variable are given: one is x variable, another is a y variable. One are dependent variable, another is a independent variable. Let's see our what is solution of a mean of this problem. Mean is equal to summation of fx divided by a summation of f. Here is a summation of fx. That means we have to calculate frequency into x variable. We get a fx variable. Let's see. Let's two table draw as usual problem is seen in, and the one another table we have to draw, that is a fx means frequency into x variable. That is, first we see the 3 into 2, that is a 6, 4 into 16, that is 64. In that manner we have to calculate overall table fx. After calculating the fx, we have to put a value of a fx and the f. Summation of f, that means summation of frequency. In this way we solve the problem of a frequency. That same manner problem is given, but problem is given in the class interval type. That also same, but there is a until of a fx, there is a xm is calculated. Xm, it is nothing but the class middle value that is calculated, and after the calculating the middle value multiplied into xm into f, and the formula is modified. That is a x bar is equal to summation of fxm divided by f, and we put in value and get it a answer. That is simply we can get it. Simply mean is given by the with the help of formula with the ungrouped data. Let's next see the merits and the demerits. Merits, it is it is easy to understand, easy to calculate. It based upon all observation. It is a familiar to common to man, and the rigidity defined. It capable of further mathematical treatment. It is affected by a sampling fluctuation. Hence, it is a more stable. Demerit, it cannot be determined by inspection. Arithmetic mean cannot use if we are dealing with the qualitative character which cannot be measured in the quantitative, like caste, religion, sex. Arithmetic mean cannot be obtained if a single observation is missing or lost. Arithmetic mean is a very much affected by the extreme values. Next point see in a next lecture. Thank you.